AB Calculus AB, Unit 8, Day 12, Office Hours, Extra Review. This is an extra assignment. Help you with probably the second part of the test, which has a bunch of motion questions on it. So here's a graph of position. When is Johnny moving forward? That'd be positive velocity, which would be the slope of this graph, which would be from 0 to 3. And we usually include the endpoints. And then positive slopes from 12 to 17. Furthest to the left on the number line. Furthest to the left. Well, that would be min position, which this is a graph of, and there it is right here. That's the min. That's the lowest point of the position graph. So it's at time equals 12. And then slowing down is when acceleration and velocity have opposite signs. One positive, one negative, doesn't really matter. So this is positive velocity, this is negative velocity, and this is positive velocity. And then the concavity gives you the acceleration. So here's a negative acceleration, here's positive acceleration. So when do they have opposite signs? Well, this is positive velocity, negative acceleration. So we're going to say 0 to 3. And we're not going to include the endpoints for concavity, but we do include the endpoints for velocity. And then here we have negative acceleration, negative velocity, that's speeding up. And here we have negative velocity, positive acceleration. So we're going to say 8 to 12. And we're going to not include 8 because it's the edge of acceleration, but we will include 12 because it's the edge of velocity. And then here we have positive acceleration, positive velocity, that's speeding up. So there you go. That's how you do it. Okay, next one, I'm giving acceleration, initial velocity, initial position, and you want to find the original equation. So we've got to work backwards. We've got to integrate twice. So we've got to start by finding the velocity, which is the integral of the derivative velocity, which is the acceleration, which is sine 2t dt. And so that's going to be, you could do U-substitution if you want, but I've shown this a bunch of times. I know it's going to be cosine 2t. I know the 2 is going to come out, so I want a 1/2 here. And it's going to be negative plus c. You could do U-substitution for that, but it's a few extra steps to just get that 1/2. Now let's use the initial condition right now to find the c. And it should come out to 3. That's a 1. So c equals 3.5 or 7/2. So the velocity equals negative 1/2 cosine 2t plus 7/2. So we're halfway there. So now position is going to come from integrating the derivative of position, which is the integral of velocity, which is the integral of negative 1/2 cosine 2t plus 7/2 dt. So what do we get? We get, well, there's already negative 1/2, and then you're going to get a sine 2t, which is going to give you another 2 that we want to cancel out so that we actually end up with a 1/2. Plus 7/2 t plus c. You could always check your answers by taking the derivative of these and see if you get what you started with. Now, the initial condition is at time 0. Plug this in. We should get 5, and these both go away, so c equals 5. So your final answer is negative 1/4 sine 2t plus 7/2 t plus 5. So hopefully you're getting the hang of that. We've been doing that kind of work a lot. Okay, next page, back page. Okay, so we have acceleration and we have initial velocity. So we should probably go ahead and try and find the velocity equation. So velocity is going to be the integral of v prime, which is going to be the integral of a, which is going to be the integral of 6t squared minus 12t dt. So we're going to get 6t cubed over 3 minus 12t squared over 2 plus c. Use the initial condition at time 0. Plug 0 into your equation, and it should come out to 0. So we get c equals 0. So your equation is going to be 2t cubed minus 6t squared. That's your velocity. Now we're trying to find when Johnny's slowing down, which probably means we need to do line checks with velocity and acceleration. Velocity, acceleration have opposite signs, right? So we got velocity here, so we might as well find its zeros. So we're going to set it equal to 0 undefined and factor it. And get t equals 0 and t equals 3. Now be careful, this has an even power on it, so it's going to bounce off the graph. So those are critical points, turning points, we often call them. And then for acceleration, we've got to set the acceleration equation equals 0 undefined. Find its zeros, places it might change sign, factor it. And we get 0 and 2. Okay, so now we have what we need for a line check. So the velocity line check, which you should label, we have 0, 3, test a value. I like to test far right, 4. It's going to be positive, negative, negative. And then acceleration is going to be at 0 and 2. And we test a value, t equals 3. And that's going to be positive, negative, positive. So slowing down is going to be here and here. But we're not going to include negative time. All right, so we're just going to include 2 to 3. We don't include the edges of acceleration, include the edges of velocity. And so there you go. That's your answer for slowing down. Speeding up would have been 0 to 2 and 3 to infinity. Minimum velocity means we need v prime, which is acceleration equals 0 undefined, which we just did the work for here. So we can use that again. So we got a t equals 0 and 2. The endpoints are right here given to us. And so we need to make a table and plug it into velocity. So I find it helpful to write that equation right here and make sure I don't plug in the wrong one. So we got 0, 2, 5. You plug 0 in, you get 0. If you plug 2 in, you get 16 minus 24 is negative 8. If you plug 5 in, you get 125. 250 minus 6 times 25 is 150 is 100. So this is your max. This is your min. So the minimum velocity is negative 8 at time t equals 2. Nice solid answer. If you need a justification, say by extreme value theorem, checking endpoints and critical points. Feel the gravity in there. Now, I'm giving you the gravity equation here, but you should not count on being able to, I'm not going to give it to you. So you're going to need to remember that S equals 1/2 gt squared plus v naught t plus s naught. For us, we're usually using g equals negative 32 feet per second squared. So the equation then becomes negative 16t squared plus v naught t plus s naught. And then the v naught and s naught will be described to you in the problem. So don't count on me giving it to you. Average velocity. Well, we could find all of our equations, I guess, real quick. Vt equals negative 32t plus 48. Acceleration should not be surprising. That always comes out of negative 32 for gravity. Average velocity is going to be, you know what? I think we got to do some work first. We got to find the endpoints. So we got time 0, but then we need to find time to impact. So we're going to set the position equal to 0, ground level, to figure out when it hits the ground. So we're going to set equals 0. So hopefully we can factor this. Otherwise we've got to use quadratic formula. Minus 5 plus 2 works out good this time. So t equals 5 and negative 2. Now, that's our time to impact. That's like going back in time. So this is time to impact. So for this equation, you know what? Actually, we didn't even need that yet. Upward flight, well, that's just up. That's from time 0 to the critical point. So we'll probably use this at some point. And part B right away says impact. And we'll need it for endpoints on part C. So we got to find when the velocity equals 0. So velocity is negative 32. T plus 48 equals 0. T equals 48 over 32. 3 over 2. So this is your critical point. So for upward flight, we're going to have to do S3 halves minus S0 over 3 halves minus 0. So S of 3 halves, oh my gosh, this is going to be interesting. Maybe we should do the work down here for max height. I think we already have everything we need. 0, 3 halves, time to impact is 5. I'm going to plug these into position. So we're going to have to do some of this work for multiple, part A and part C. So I'm just going to do it down here. You can make so if you plug 0 in, you get 160. Plug 5 in, you should get 0. You can double check it. Plug 3 halves in, this is where it gets a little fun. This is 9/4 plus 48 times 3 halves plus 160. So that's going to be negative 36 plus 72 plus 160 is going to be 196. Right? 196. So that's what we need right here. 196 minus S of 0 is 160. So that's going to be 36. And we're going to multiply by the reciprocal. So it's going to be 12. That's going to be 24 feet per second is your average velocity. Okay. Now, velocity impact, we're just going to plug impact 5 into your velocity equation. We already found time to impact. It's going to be negative 160. It's going to be negative 112 feet per second. And it makes sense it's negative. It should be when it's coming down. So that's your velocity impact. And then we've done a lot of the work for max height. We found the critical point, found the endpoints, made a table. This is your max. This is your min. So the maximum height is 196 feet at time t equals 1.5 seconds. Units. Good answers from max mins. Justifying it saved by extreme value theorem, checking endpoints and critical points. So that's it. Hopefully some good extra help to get you ready at the last minute.